Lesson 18 is on like terms and the addition of like terms. Now remember, we learned in Lesson 17 that a term is thought of as a single entity or thing or set of variables and numbers that represent or have the value of one particular number. So in other words, whatever that term is, we could substitute numbers in, just like in our evaluate expressions, and we could come up with one number for an answer. Now like terms, when we think of them, for example, this term right here, 6abc, and this term right here, 3bca, we would consider those like terms. And when we think of like terms, we just look at the letter part of it, not the numerical coefficient. We just look at the letters, and we see that both of them have A, B, C in them. And we remember 6 in front, that's a factor, and then everything's multiplied. 6 times A times B times C. And then the 3 in front of BCA, that's a factor as well. Everything's multiplied. 3 times B times C times A. And so in multiplication, the order doesn't matter. So we could rewrite this one as 3ABC. And so now that variable part of the letter part, it looks just like the first one in the 6ABC. They both have A, B, and C in them. This is something real important to remember, what I have in red up there on the board. To determine if terms are like terms, just consider the variables, not the numerical coefficient for that particular term. And then remember too that order does not matter in multiplication. ABC in 6ABC, that's the same thing as the BCA in 3BCA. All of those are factors. All those letters are variables. Those are all factors of each other. And so the order of them does not matter. And that's something you're going to want to do when you're working with like term problems, is to rearrange all the variables to see if they are in fact like terms or not. And so that leads us to our next section on addition of like terms. And I've got a practice problem there. Let's just go ahead and do that. Let's add the like terms in that problem. So first what you need to do is just look at them. You have 3 terms there, 3xy, 2x, and 4yx. Now, think about it. There are some like terms here. And you have an x and a y. Remember, when you're thinking of like terms, you just look at the letters. You don't worry about the numbers. And then you have a yx over here, but that's the same thing as xy, right? So you can just rewrite this. And what I like to do on these problems is to rewrite them and put the like terms next to each other. 3xy plus 4xy plus 2x. 2x is not a like term in this problem. It doesn't have another term that it is similar to. To add these like terms, all we do is add the numerical coefficients. 3 plus 4. That's equal to 7. And then we have xy on the end, plus 2x. And so that's the simplified form of that expression. We've simplified it because we've added the like terms, and now we just have 2 terms instead of 3. Look at practice problem B. Let's simplify this by adding the like terms. And so just look through the problem here. We have an x, we have a 2y, a 4, and a 3y, and a negative 1. Now, the 4 and the negative 1, those are terms, and those are like terms. So let's just put a little blue mark underneath them to remind us that those 2 are like terms. And then we have the 2y and the 3y. Those are also like terms. So let's put a red mark under those 2, and that will remind us that those are like terms as well. And this is something you might want to do on your problems as you're trying to learn how to add like terms, is to mark them with different colors so that you can remember which terms are like terms. And then go ahead and do the addition. And so now we have x. Let's just go ahead and add the 2y and the 3y together. And remember, we include the sign in front of them when we're considering the term. So it's plus 2y and plus 3y, so that would be plus 5y. And then the 2 numerical coefficients, those are a positive 4 and a negative 1. So let's add those 2, and that would just be a positive 3. So there's the simplified form of that expression, x plus 5y plus 3. Look at practice problem C. We have three terms there, xyz plus 3zyx minus 5yxz. Now, all of those are really like terms, aren't they? Because they all have x times y times z in them. They're just in different orders, and we remember that in multiplication the order doesn't matter. And we just look at the variables or the letter parts. We don't look at the numerical coefficient to determine if they are like terms or not. So really all we're doing here is we're adding xyz, which actually that's 1 xyz, right? It's understood that there's a 1 out in front there. So we'd have 1 plus 3 plus a negative 5, or 4 plus a negative 5. And that would just be negative 1 xyz, or just negative xyz. We don't need to write the 1 on there. And so that would be the simplified form there is negative xyz. Let's do another one. Practice problem D. 2xyz minus 4 plus yx plus 5xy minus 7yxz. I want you to simplify that problem by adding the like terms. Well, let's just go through this. There's several different terms in here if you just look at it real quickly. And we can see that there's an xyz. So there's another yxz, which is the same thing as xyz. So let's underline those in blue so that we know that those two are like terms. And now we have a yx and an xy. So those are like terms as well. So let's underline those in red so that we can remember that those are like terms. And then we just have that negative 4 there by itself. So let's go ahead and start to add these up. Let's add the xyz's first. We add the 2 and the negative 7. That would be negative 5 xyz. And then we have the negative 4. Let's just put that here. And then we have a yx, a positive yx, or a positive 1 yx, in other words, and a positive 5 yx, or xy. And so we can say positive 6 xy. I'll just put those in alphabetical order. And so there's our simplification of that expression. Now remember, in addition, the order doesn't matter either. I could have put negative 4 first, then minus 5xyz, then plus 6xy. The order doesn't matter. So in the answer key or the solutions manual, if your order of addition is different than what they have in the solutions manual, the problem is not wrong. You just have to have the correct terms. Now if you had a positive 5xyz instead of a negative 5xyz, that would be wrong. But the order that those terms are put in your answer, that does not matter. So when you're doing these problems, it's important to know what does matter and what does not matter to figure out how to correctly answer them. Okay, well that's all for lesson 18.